I'm Bonnie Grossen, Executive Director for the Center for Applied Research and Education, also known as CARE. And CARE is affiliated with the University of Oregon. In weaving together basic skills with algebraic concepts, there are some important instructional principles that kind of help guide that process. And one is that you don't have to have the same topic occur for the whole lesson. It's good to have some tracks so that might have like 10 or 15 minute segments where you're working on something you began yesterday. For example, students who don't know their math facts, you don't want to do a whole period of math facts. You might do 3 minutes of a review of multiplication facts. Have another little track that is developing an algebraic concept, like maybe an algorithm for finding an unknown in a certain position. And then as they're learning some of the basic skills, you don't want to have the conceptual problems require skills they haven't learned, because the success is an important part of making them willing to put out the effort. As they feel successful, then they put out a lot more effort, and everything starts to work together. So, the curriculum has to be extremely well organized, and review built in. The review should be masked initially. When students are learning a concept, they should have enough practice so that they actually can, do the algorithm or do the procedure. And then after that, the review should be distributed. We find that distributed practice leads to retention. And that means just a few problems every day, not a whole page of one type. And then it should be cumulative. The different things students have learned in the past should be reviewed in this distributed practice. And the review the practice shouldn't, take up the whole period. It should be another one of those little segments in the instruction. One of the issues we have in math education and all education, as a matter of fact, is, when to use student-centered or small group instruction and when to have teacher-centered or explicit instruction. And one thing is quite clear: explicit instruction is more democratic than student-centered discovery groups. When students have to figure out the concept without any initial presentation from the teacher, then some students get the concept and others don't. And even if the teacher comes in and asks questions, it's hard for the teacher to respond to the kids who are not getting it when there are some that are getting it, and it just ends up being a focus on those who are getting it and the teacher feeling like the class got it when actually there's a large number of them who are still confused. So the most democratic method for initial presentation is, we say, make the strategy conspicuous. And that can be explicit. That can be the teacher illustrating on the board, but there are other ways also to make math strategies conspicuous. The appropriate place for students to do group work is in applications or in making the review more interesting. Structured activities where the students work together to monitor each other's practice and have little challenges, and that makes the review and practice interesting. And then having students work together in groups where they're applying the concepts they learned to maybe more complex applications, where they can put their heads together to figure out how the things they've learned might apply to this new situation. A real important tactic for teachers to use is scaffolding. And however strategies are made conspicuous, the students may often need continuous scaffolding or some guided prompting. So if teachers are completely involved with students while they're working, after they're finished working, looking at their work all the time and responding to that, they're doing a kind of formative assessment. One of the things we've done with students who are weak with their multiplication facts, we've put little tables in the back of their book that they could refer to that have the factors across the top and bottom and the multiples, on a little grid sheet, rather than giving them calculators. Calculators are more opaque. Now, one of the things that's become very popular in high schools is for students who are not quite ready for algebra, the school will take the regular algebra course that's taught over a year, and divide it into 4 pieces and take the first piece, the first quarter, and then teach it in a full semester to students who are behind, and thereby taking 2 years to get through algebra. Now, when you do that, you don't have anything engineered into that textbook that helps the teacher teach those missing basic skills. You're just going more slowly through the same algebra course. And we've found that if you really spend some time engineering the instruction, planning the examples, and building in some of that pre-skill instruction into the textbook, it can be very helpful for the teacher. A well-engineered text is going to help the teacher make progress more efficiently and effectively. High schools need to provide for students who don't have the pre-skills for algebra a course that's designed specifically for them, that is engineered to teach the pre-skills they're missing, the concepts of proportions and ratios and the relationship between decimals, fractions, and percents. Those kinds of things are built in as they're being led into algebra, rather than just taking the standard algebra course and dividing it into chunks and taking 2 years to teach that same content. There has to be a smarter design to the curriculum to catch those kids up. And it can be done. We know it can be done.